This is a video from the Exam 3 review. We're going to determine if the sequence converges or diverges. If it converges, find its limit. And let's take a look at 1c. Suppose a sub n is equal to negative 10 to the n divided by n factorial. Now, what we're going to do is we're going to consider the summation from n equal 1 to infinity of negative 10 to the n divided by n factorial. And we're going to look at and determine whether this series converges or not. Now, I'm going to apply the ratio test. A sub n is negative 10 to the n over n factorial. Now remember, we're applying the ratio test on the series, not the sequence. A sub n plus 1 is negative 10 to the n plus 1 divided by n plus 1 factorial. And so this is negative 10 to the n times negative 10 divided by n plus 1 times n factorial. Okay, I want to look at the limit as n goes to infinity of the absolute value of a sub n plus 1 divided by a sub n. And this is the limit as n goes to infinity of. Now, a sub n plus 1 is negative 10 to the n times negative 10 divided by n plus 1 times n factorial. And then I'm going to multiply by the reciprocal of a sub n. The reciprocal of a sub n is n factorial over negative 10 to the n. But the negative 10 to the n's cancel, the n factorials cancel, and remember the absolute value of negative 10 is 10. And so this is the limit as n goes to infinity of 10 over n plus 1, which is 0, and that's less than 1. So what this tells me is that the summation from n equal 1 to infinity of negative 10 to the n over n factorial converges absolutely and therefore converges by the ratio test. So we know this series converges. And so therefore, the limit as n goes to infinity of negative 10 to the n over n factorial, that's forced to equal 0. And so that tells me that the sequence converges to 0. And that's how we do, this is 1c. And let's take a look at 1d. Now, in 1d, we have a sub n is 1 plus 3 over n to the 4n. Okay? Now, what I'm going to do is I'm going to set y equal to 1 plus 3 over x to the 4x. Take the natural log of both sides. This is a Calc 1 related problem. Now, I can pull the 4x out in front and say natural log of y is 4x natural log of 1 plus 3 over x. But remember that x is 1 over x. And so this is 4 natural log of 1 plus 3 over x divided by 1 over x. Okay, now the limit as x goes to infinity of. Now, the numerator is 4 natural log of 1 plus 3 over x. And we're going to divide by 1 over x. But this is of the form 0 over 0. So, by L'Hopital's rule, this is the limit as x goes to infinity of. The bottom is negative 1 over x squared. The top is 4 over 1 plus 3 over x. But remember, by the chain rule, we have to multiply by negative 3 over x squared. That's the derivative of 3 over x. Remember, the derivative of 1 is just 0. Okay? Now, the x squareds are going to cancel. And remember, negative 3 over negative 1 is just positive 3. And so this is the limit as x goes to infinity of 12 over 1 plus 3 over x, which is equal to 12, because as x goes large, that term goes to 0, the term in the denominator. Now, what does that mean? What this means is the limit as x goes to infinity of natural log of y is 12. But I don't want that. I want the limit as x goes to infinity of y. But that's the limit as x goes to infinity of e to the natural log of y. Remember that the exponential and the natural log, e to the x and natural log of x, are inverses. But that's e to the 12th. And so that implies the limit as x goes to infinity of 1 plus 3 over x to the 4x is e to the 12th. And therefore, the limit as n goes to infinity of 1 plus 3 over n to the 4n is e to the 12th. And so this sequence here, hold on. So 1 plus 3 over n to the 4n must converge to e to the 12th. And that's how we do 1D. Number 2. Suppose a sub n is 2n minus 3 divided by 3n plus 4. A sub n plus 1 is 2 times n plus 1 minus 3 divided by 3 times n plus 1 plus 4. But that's 2n minus 1 divided by 3n plus 7. Okay? Now, here's the deal. I'm going to take a sub n plus 1 and I'm going to subtract off a sub n. And you get 2n minus 1 over 3n plus 7 minus 2n minus 3 divided by 3n plus 4. Let's get a common denominator. The common denominator is 3n plus 7 times 3n plus 4. So I just want to write this as a single fraction. So in the numerator, we get 2n minus 1 times 3n plus 4 minus 2n minus 3 times 3n plus 7. Okay? I hope that's okay. Now, if I distribute, now in the denominator I get 3n plus 7 times 3n plus 4. In the numerator I get 6n squared plus 8n minus 3n plus 5n minus 4. And then I get 6n squared plus 14n minus 9n plus 5n minus 21. That's interesting, because the 6n squareds go, the 5n's go, and what we have left looks to be like 17. And then on the bottom, we get 3n plus 7 times 3n plus 4. And that's greater than 0 for n greater than or equal to 1. What does that imply? That says a sub n plus 1 minus a sub n is positive. What does that mean? That means an less than an plus 1 for n greater than or equal to 1. And so that says this sequence is increasing. Now, this is not on your review, but it's worth noting. This sequence, a sub n, is bounded below by a sub 1, which is 2 times 1 minus 3 divided by 3 times 1 plus 4, which is equal to negative 1/7. A sub n is bounded above by, there's lots of choices. If you look here, 3n plus 4 is bigger than 2n minus 3. For n greater than or equal to 1. The denominator is bigger than the numerator. And so we can actually say that this sequence is bounded above by, doesn't matter. I'll even say 2. It can't get bigger than 2. And so what that tells me is a sub n is bounded. All right? And therefore we can conclude, and so I'm just adding a little bit more to your review, is that we can conclude this sequence converges. Okay? And that's number 2 and a little bit more. Now, number 3. It says, give an example of a sequence that is increasing and diverges. And so there's lots of different possibilities. Remember that the key is that it can't, the limit has to go off to infinity. And so a possible solution is a sub n equals n, or we'll even say n squared. So notice how the limit as n goes to infinity of n squared is infinity. And n squared most certainly is less than n plus 1 squared. Okay, that's going to conclude this video. And oh, by the way, this one is number 4. I mistakenly did 4. So we did 1C, 1D, 2, and 4. I will do 3 in another video. Okay, thank you.